I still have mental. I have mental one and
All right, everyone, shut up. We're starting. So, welcome to the CAD and laser cutting and 3D printing workshop. Today, Nicole's going to go through CAD first and CAD and laser cutting, and I'll be doing 3D printing. Wait, is that food up there? Is that food up there? Yeah, will be food up there. Just confirm. And yeah, make sure you sign the out form, which will be on. Where is it? Yeah, make sure that all of you have signed out form, right? Hopefully so. Yep, right. Yeah. So yeah, for our CAD portion of the workshop, we're gonna be first starting with 2D sketching, which is how you usually in most CAD programs start by making a shape. So you have to start from a 2D plane, and then we create that into a 3D shape. Then we can get multiple, to make more complicated shapes, you can get multiple 3D shapes and combine them and do Boolean operations such as cutting, joining, and such as doing an AND operator, so you get an intersection. Afterwards, we can get the file, make an STL for printing, and also we will run through some stuff to focus on how to design for 3D printing. And I'll pass it on to Nicole for the CAD portion.
So for CAD, we'll be using CAD to create 2D drawings and 3D drawings. So we're gonna use SolidWorks for CAD, and then we'll be making a shaft key and a keyhole. So I'll be demonstrating that on SolidWorks. So if you don't have SolidWorks already, you can go to UNSW My Access, and then you can find SolidWorks on there. I'll give you some time to open your SolidWorks, and then I'll start the demo.
pictures for math. You got pictures for math. Take one and then send it to the chat. Is there a SolidWorks on the laptop? I don't know. Can you make them like do the stuff?
So if everyone is ready, I'll be starting the demo. So when you open SolidWorks, just click on the part. So we will be making a part. And then just select any of the planes. One of the planes, front, top, or right, it doesn't matter. And then press sketch. Is everyone following? And then we'll be starting with a rectangle.
Now guess the graphics card. It's a good
Are you guys okay with the rectangle? Can I have a thumbs up if you're okay with the rectangle? Yeah, okay. And then to dimension it, you just press Smart Dimension, and then you basically just do this. So after dimensioning the rectangle, we will add two arcs. So we will use the tangent arc here, and then we'll make an arc here and an arc here. Is everyone okay with the arc? Can I get a thumbs up if you're okay with the arc? Okay, after the arc, we're gonna use the trim entities to trim away this part that we don't want.
Honestly,
So now we have the 2D sketch of the key, and then we're gonna make it 3D. So we're gonna use the extruded boss, and then that's how you extrude it. And then let's do a 3 mm extrude. And there you have a 3D shape.
How long did you not very long. The other one was serious.
What is this question?
Oh, sorry.
So I'll repeat the part where we extrude the sketch. So when you get a sketch like that, just go to extruded boss base. And then you will type whatever height you want here. So mine was 3 mm. And then just click the tick. And then there we have a 3D sketch. After this 3D sketch, we're gonna be doing a chamfer. So just go to fillet and then click on the little arrow and press chamfer. After that, just click on the edge. And then here, I'll do a 0.2 mil width of the chamfer. And then there you have it, a chamfer on the edges. If anyone didn't get the chamfer part, I'll repeat it again. So under this fillet, you see a small arrow. So just click it and click chamfer and then click on the edge. And then here you can change it to whatever width you want. So I'll be using 0.2 mil and then just click the green tick. And then you have the chamfer on the edges. Okay, so now that we've finished the key, it's your turn to make the key shaft. So I'll give you guys a tip. This thing only requires 2 steps. So just create a new part and then start making your key shafts. Hi, can I have your attention, please? Hi. So for the key shaft, we want the key to be able to fit inside the shaft. So later we'll be assembling it so that the key fits inside the key shaft, okay? So just make sure your shaft is bigger than the key.
Also, quick announcement to everyone. In SolidWorks, right, the zoom direction when you scroll is really weird, so I highly recommend reversing it. That is all. The zoom direction.
No, I need to check something.
Hi, can I get your attention, please? Since most of you are done, I'm gonna just demo on how to do the key shaft. So we're just gonna do a triangle and dimension it. And then we're gonna make another rectangle. And then after that, we're gonna do an extruded boss. So this is how we get the key shaft.
Oh yeah, this is the battle royale one. Yeah, yeah.
Hi everyone, if you're done with the key shop, we're gonna move on to an assembly. So basically we want to put the key inside the key shop, so we're gonna use assembly to do it. So you go to files and you click on make assembly from part. And then you just click the tick, and then you have your part here. And then you go back to assembly, insert components. And then drag the key inside. I'm gonna move on to mating the key and the key shaft. So as you can see, the key and the shaft can be moved. The key can be moved freely. So we want to put this key into the shaft. So what we want to do is we want to mate, and then you can just select this face and select this face. So this will make this face parallel to this face. And then after that, we want to make the top face and the top face inside the shaft. And then there we have it. It fits inside the shaft and it's only allowed to move like this. Hi, if everyone is done with the assembly, can I have your attention, please? Can I have your attention, please? Hey guys, please, I'm trying to speak here. Thank you. So we'll be moving on to laser cutting. So if you want to laser cut your CAD, you basically just create the file. And then there's a few layer types for laser cutting. And then after that, you send your file. You convert your file to the DXF and then send the file and add the file to the laser cutter, and then it will just do its job. So in the makerspace, we have the Rhino laser cutter. So if you want to laser cut something, you have to make your file a DXF file. So basically, you just go to Save As, and then under the file type, just change it to DXF. Everyone got that? So if you want to save a file with My Access, just follow these steps. So save the file on My Access, and then open My Access File Manager, and then go to My Access File System, copy, and then on your personal file system, just paste. So there are a few layers in Rhino. So we have these 4. For this color, it will be engraved, and then for this color, it will be a light score, and then for this color, it will be a dark score, and then if you want to cut something out completely, it will be this color. So don't worry about this too much. When you get your laser cutting badge, the makerspace, the people in the makerspace will probably go through this with you guys. So as I've said earlier, basically just convert your file into the DXF file, and then you use the Rhino laser cutter, and that's it. Yep, so everything that I've mentioned there was pretty brief, but when you get your laser cutting badge, the staff in the makerspace will go through all of those with you, so you get a better idea of laser cutting. Now we'll move on to 3D printing, and I'll pass the mic to Jay.
Greetings, gamers. So we will move on to 3D printing now. So fantastic technology. 10 out of 10 would recommend. Yeah. So it's a 3-step process. We start with when we have the file. We got the file. We have to convert it to an STL because 3D printers can't really use the files that we make because they're all proprietary. Then we get an STL file. We still can't put that in the printer yet because we need to slice it into G-code. So we can use a slicer such as Cura or process slicer to do it. Then we send it directly to G-code to a printer. So that's the process in summary. We will go into more detail next slide. So just now you have learned how to design like a basic key and keyhole. But when you actually design for a robot, like or actually making something a robot, there's a bunch of rules you have to follow. And those are like those are some pretty good rules of thumb, except they are not always fully accurate to to modern 3D printing tech. But they're still good to follow. The most important ones are such as for supports and overhangs, you don't want to go a too steep angle because stuff will fall due to gravity. And also for like when you have parts that are connecting, you want to have a bit of a gap, otherwise they will not fit together. I recommend the gap is to 0.2 mils. And that should, and your part should fit together decently if you have a 0.2 mil gap between, like, let's say, the key and the keyhole that you designed just now. Moving on. Yeah, as you can see, that's the beauty of a logos toilet. So, different CAD programs have different ways of creating STLs. If you're using Fusion 360, you just go to each body on the left side, click on the body, right click on it, click Save as Mesh, and then in the Mesh option, select STL binary, refinement height, and make sure you don't check Center 3D Print Utility. Press OK, and then you have STL. In SolidWorks, you just do a Save As, and that should be good. All right. So then when you have your STL file, which is composed of a bunch of triangles in 3D space, and that's only like an outer surface compared to an actual solid in, let's say, like an SLD PRT file. We still can't use center print. We need to slice it into G-code, which is basically a set of instructions telling the printer where where to go at what time, and then to extrude how much filament per move, whatever. In this slicing process, we can input our own parameters and stuff, such as temperature and layer height and spore thickness, all that kinds of stuff, because it's very important for deciding how our print is going to add up. Yeah, moving on. So here are some of the key slicing settings that we should keep in mind of when we print. One of the most important is on temperature. We should set that to each filament type and filament brand will have its own temperature for CAD. You kind of have to experiment with it. But usually 200 degrees for the filament and 60 degrees for the dip bed when you're printing PLA is good because we usually print in PLA nowadays because it's easy to do, it's easy to use and it's pretty cheap. And it's also quite thin and quite strong actually. For layer height, it's a bit like our resolution. Higher layer height will print faster, and lower layer heights will be more detailed. Infill and wall thickness will directly correlate to strength. If you want a stronger print, it's often better to increase the wall thickness first than to increase the infill, because measure like a pipe. Most of our strength will be on the outside of the pipe. Support is useful when you're printing, when you're trying to print something that's anti-gravity, when you want to extend something that's horizontally out, and normally we just drip down. You would just click the generate support option to deal with that. And fine is something that if you're printing something that could potentially get messed up for the bed, for example, you just there's a couple of fusion options you can select, such as a brim or a rough. Yeah, and finally for printing, pretty simple. Just when you have the generated GPIF file, put it in an SD card, stuff in the printer, and just hit print. And it will basically automatically do it for you. There's a couple other ways of doing it, but you don't really have to worry about it because making space stuff will deal with it. And that concludes our workshop, I think. Any questions?
Yeah, so pretty much for your Sumobots design, most of the designs you can either 3D print or laser cut, but do whatever feels more like comfortable to you. So usually you can also probably like design some of it using 3D printing and then do like the rest using laser cutting. So there's definitely a lot of ways you can kind of modify your designs. Yeah, does anyone have any specific questions? No, okay. So it is just check the time. We have about like more than half an hour left to this. Oh yeah. Okay. Let us gonna talk about Unbound.
Oh yeah, if you guys were here last week, you might remember that we mentioned that you can get 10 days of industrial training just by doing Sumobots. So just a reminder, if you're still interested in that, please go ahead and sign up on the Unbound website. Just like let me know if you have any questions. But yeah, this is like the easiest way to get 10 days of industrial training if you're doing engineering. So like yeah.
Yeah, so for the rest of the workshop, feel free to do some more brainstorming and then let us know if you have any questions. And we'll have food in a bit as well. All right, food is ready at the back. It's first come, first served. But please take one. Let's go.